Welcome to the first instructional video on electricity. The first video is going to be defining terms. We're going to be defining 4 terms: the volt, the amp, the ohm, and the watt. We're going to be talking about voltage, currents, resistance, and power. And these are just useful terms. You're going to need to know them in every single other video I make. You're going to need to know them to function in the world. Okay, first term is the volt. The volt is the unit of measurement for electromotive force. I'll write that down. Or EMF. The volt is, in mathematical formulas, almost always abbreviated E for electromotive force. A volt is specifically 1 coulomb of electrons doing 1 joule of work. A coulomb is 6.25 times 10 to the 18th, and that number of electrons doing 1 joule of work will create 1 volt. And that means a volt is a very specific, precise measurement, and even as it's derived in different formulas, you will always create the same 1 joule of work, 1 coulomb of electrons. There's a very common analogy that we use when dealing with electricity, and it's the water, the plumbing analogy, because it's easy to visualize. And in this analogy, voltage will actually be the pressure, the actual force, or the height of your water tower. It'll be the force with which electrons are pushed through a conductor. More on that later. Okay, the second term that we're going to look at is the ohm. The ohm is always abbreviated as omega when you're dealing with calculations, and it's the unit of resistance. In the water analogy, it's the shrinking of the pipe. You'll have a certain amount of pressure, you'll have a certain size pipe, and as you try and push pressure through it, the smallness of the pipe, if you will restrict the flow. And that's like an ohm. It resists movement of electrons. In reality, what it is the bonds between electrons in many substances will release the electrons. It will be easy for electrons to flow, such as copper, silver, gold, aluminum. But if you get into other different materials, what are they? Silicone, germanium. The electrons won't easily break their bonds and flow in organized patterns, and this will create more resistance. Obviously, if you have a smaller amount of copper or a smaller amount of aluminum, there will be less actual electrons that are able to go through there. There will be less electrons that are available to be pushed through that wire. And so as you make the material less conductive, or you make the actual material smaller, you're going to have a larger resistance. There's a lot of other things that will affect the resistance, but in general, if the wire is longer, if the wire is thinner, you'll have a higher resistance. The other thing you need to learn, just keep in the back of your mind about resistance, is that it is almost always associated with heat. If you take that same length of wire and you heat it up, there will be more resistance. If you heat up as you push electrons through a wire, the wire will heat up, and that will be resistance. This is important just to keep in the back of your mind, because especially when it comes to like PV or transformers or semiconductors, as the temperature around a wire changes, the tolerance of that wire will change as well. And as you group wires together, because of the resistance inside the wire, they will get hot, and you have to account for that when you're deciding how many wires you can put in a conduit. Enough with that. The ohm, omega, resistance, heat. All right. The third term we're going to do is the amp. Write it down. The amp is abbreviated I standing for intensity. There you go. So as you learn them, and I made this mistake myself, don't just instantly, when you see volts, change it to a V on your homework. Just keep it as an E, learn it, love it, enjoy it, because it's always going to be an E, and your life will be easier if you just learn to accept it. An amp. An amp is one coulomb, and that's 6.25 times 10 to the 18th electrons past 1 point in 1 second. And that's a very precise number of electrons past a singular point in space in 1 second will give you 1 amp, which means amps is a very precise measurement and can be used to derive other measurements. It's not amorphous, it's not... See, so many times when we think of these measurements like hundreds of amps or 0.003 amps, you know, there's this tendency to be like, oh, plus or minus, you know, screw it. But the fact is, if you can get down to the number of electrons that go past a point in 1 second, you can be very precise. Like 1 milliamp is something you can measure and be very confident in it, and it's something you can actually derive through formula and be confident that that's going to come out right. It's watts. Voltage times current equals watts, which means watts is a derived measurement, but it's also a very, very useful measurement. We use it constantly, and it's generally accepted, and it's the very first formula you'll learn, and it will actually be plugged into Ohm's law in the next video, and we will derive 22 different formulas from these two formulas, and it's important to learn. But watts, usually designated with a W in calculations, and its entire definition is volts times amps.